In the world of high stakes technology, words are usually chosen with extreme caution. But last week, Nvidia decided to skip the corporate pleasantries in a move that has sent shockwave through Silicon Valley and Wall Street. Nvidia publicly declared that its next generation chips aren't just better than the competition, they are a full generation ahead of Google's internal TPU design. And what is the context? For the last 3 years, Nvidia has been the undisputed king of the AI era. Their H100s and the Blackwell chip are the digital gold powering every major LLM you have ever used. But while the Nvidia was dominating the headlines, Google was quietly building its own empire. Google's Tensor Processing Unit, or the TPUs, have been the secret sauce behind the Gemini and nearly every AI breakthrough at the DeepMind. What is the conflict here? For a long time, there was a peaceful coexistence. Google bought Nvidia chips for its cloud customers while using TPUs for its internal projects. But the peace is over now. Reports recently surfaced that the Meta, one of the Nvidia's biggest customer, is looking at Google's TPU as a legitimate alternative, and therefore Nvidia's response is a bold, public mic drop, claiming that while the Google GPUs are good, they are effectively looking at Nvidia's tail light from a year away. Today we are breaking down the generation gap. Is Nvidia truly untouchable, or is this the first sign of desperate incumbent feeling the heat? When Nvidia says there are generation ahead, they aren't just talking about the raw speed, they are talking about the architecture and the ecosystem, the Blackwell and the Rubin factor. As we sit here in early 2026, Nvidia is rolling out the Rubin architecture. This follows the Blackwell chip that dominated 2025. Rubin isn't just a chip, it's a supercomputer on a tray. It features the new Vera CPU and ultra high speed HBM4 memory. Nvidia's argument is based on three pillars. First, versatility. A TPU is an ASCII and application specific integrated circuit. It is specialized scalpel design specifically for Google's framework like JAX and TensorFlow. Nvidia's GPU are the Swiss Army knife of the world. They run everything. Next is the software. This is the big one, and it is also known as CUDA, CUDA. Millions of developers are locked into Nvidia software. Moving a massive AI model from Nvidia to TPU isn't as simple as clicking an export. It requires months of engineering work to rewrite the code or kernel, etc. Third is the inference dominance. So Nvidia's latest chips are using a technology called the disaggregated inference. They have split their workload so that the different parts of the chip handle different parts of the AI and also the thought process. They claim this makes them 10 times more efficient than anything Google has on the market today. So to Nvidia, Google is playing a checkers while they are playing 4D chess with entire data center. Now let's look at the other side. If Nvidia is so far ahead, why is Google currently the only company on earth that has trained a model to rival GPT-4 entirely on its own silicon? Enter the TPU version 7, also known as Ironwood. Google recently introduced the V7 Ironwood generation. While Nvidia focuses on being the best for everyone, Google focuses on being the best for the scale of the internet. And here is why Google is winning the value war. First, cost efficiency. TPUs are roughly 2 times cheaper than Nvidia GPU at a scale. When you are a company like Meta or Anthropic spending billions of dollars, A 50% discount on your compute bill is enough to change your entire business model. The pod, in within quotes, and that is the architecture. Google doesn't think in terms of individual chip. They think in pods. A TPU version 7 pod can link over 9,000 chips into a single unified machine using optical circuit switching. This allows for nearly linear scaling, meaning if you double the chip, you actually get double the power, something that's much harder to achieve with traditional GPU clusters. Third is energy efficiency. TPUs are designed to do one thing: matrix multiplication. Because they don't have the extra baggage of general purpose GPU, they consume significantly less power per flop. In a world of rising energy cost and power grid constraints, performance per watt is the only metrics that matters to CFOs of big tech giants. So why do Nvidia choose not to make this aggressive claim? It all comes back to single headline: Meta is flirting with Google. For years, Mark Zuckerberg has been Nvidia's best friend. Meta has bought hundreds of thousands of H100s, but recently report leaked that Meta is negotiating a multi-billion-dollar deal to use Google TPU in their upcoming 2027 data centers. Why does this matter? If Meta switches, the gold standard of Nvidia is broken. It proves that you don't need CUDA to build the world's best powerful AI. Let's not forget the third player in the room, Microsoft. Just days ago, Microsoft unveiled the Maya 200, claiming it's the most, for performant first-party silicon from any cloud provider. We are moving away from a world where everyone buys from the chip guy, which is Nvidia, into a world where every cloud provider like Google, Amazon, and Microsoft build their own engines. So Nvidia's generation ahead claim is the defense of their premium price tag. They are essentially telling Meta and Microsoft, go ahead, try their cheap stuff, but when your models take twice as long to train, don't say we didn't warn you. As we wrap up, let's look at the scoreboard. Nvidia still holds about 90% of the market. Their technical lead is real, and their software ecosystem is a fortress. When they say they are a generation ahead, they are likely referring to their interconnect speed and their ability to run any model anywhere immediately. But Google has something Nvidia doesn't vertically integrate. Google owns the chip, the fiber optic cables, the data center, and the cloud platform, and the AI model itself. They don't have to pay Nvidia any tax.
The vessels was intercepted on December 8, 2020.
The verdict is the generation gap. The generation gap is narrowing. Nvidia is the Ferrari unmatched in raw speed and prestige, but Google's TPUs are becoming the high-speed rail of AI. More efficient, cheaper at scale, and perfectly integrated into infrastructure. So if you are a developer, you are likely to sticking with Nvidia for now, but if you are a CEO or a CFO looking at $10 billion infrastructure bill, Google's generation behind chips are starting to look like a very smart investment. The AI hardware race has officially entered its most aggressive phase yet. Nvidia is no longer just competing against other chip makers, they are competing against their own customers. So friends, what do you think about this? Thanks for joining live, and if you found this breakdown helpful, hit that subscribe button, and I want to hear from you in the comments. Is Nvidia generation ahead claim a fact or just a desperate marketing play to stop the Meta exodus? Let's talk about it in future, and I will catch you again in the next one.